Okay, YouTube, this is my beginning of the last of a series of videos in which we're graphing trig functions. And in this video, we're going to be discussing horizontal translation. So horizontal translation, fancy term for horizontal shift. So we've observed some facts about these functions, and we say, we'll go ahead and take a look at these two right here, but these functions of the form y equals, say, a sine bx plus c plus d, where this c value is new if you're tuning into this video and have watched my previous videos, but essentially we know some things about this function already just by looking at a. So for instance, with at least sine and cosine, we say the amplitude of the graph is the absolute value of a, or we say the period, at least in terms of sine and cosine as well, we say is 2 pi over the b value, that's the period of this graph. Other things we know, we say, well, if a is negative, I should write an if here. We say if a is negative, then we say it's reflected about the x-axis, so we know this. Also this, we say d is the vertical shift, or the vertical translation, essentially. Okay, so knowing this, then we can move forth and say, well, what's the value of c got to do with it? So we're just going to look at a couple examples here, and I think the best thing to do is to table them out. But you notice that I've loaded us up with a c value here this time. So we say sine of x is what our normal graph is. We're going to graph sine of x plus pi halves and say, well, what effect did that have on the graph? Now I say, please and thank you, let's graph this from negative pi halves out to 3 pi halves instead of the normal between 0, we say our x value is between 0 and 2 pi. Now I've chosen some convenient input values, but let's talk about why. So if I were to plug this x value in for x right here, we'd say then I get sine of negative pi halves as my input, plus a positive pi halves, which, by the way, those are opposites and they cancel out. So you get sine of 0. Now recall that the sine of 0, this unit circle thing, this circle centered at the origin of radius 1, it tells us the cosine and the sine values respectively at all of the angles on its perimeter, or angles that cast a ray that strike its perimeter there. But essentially, these are very convenient to navigate with. So we say sine of 0 right here is the sine value is 0. So we say, well, what if I plugged in 0? Well, sine of 0 plus anything is itself, so this would be sine of pi halves once you add 0 to that. So sine of pi halves is up here, we get 1. So we get 1 is the output. Sine of pi halves. Now, sine of pi halves plus pi halves, I'll write it, but that's 2 pi halves, which is just pi, which is, by the way, right here. So we say the sine of this is 0. So we've gone from 0 up to 1, down to 0 again. This should look familiar to us. We say sine of pi plus pi halves. So that's 3 pi halves. That's down here. Sine value is negative 1. And then what do you know? We're going to get back to 0. But this is the reason why we say sine of input 3 pi halves plus pi halves. And we get 4 pi halves, which is 2 pi. So we say 0 again. So basically, this goes to our normal cycle. This is our normal trig function here, sine curve. You'll notice that we have an amplitude of 1. The a value is 1. So we say the amplitude, just saying here is the absolute value of 1, which is 1. We say the b value is 1. You can see that's the coefficient of x in here, but we say its period is equal to 2 pi over b, which is 2 pi over 1, so equal to 2 pi. Let's put a box around that way. So we know these things about the graph. It has no d value, so no vertical translation. The a value is positive, so it's not reflected. But going and graphing these, we say, starting at negative pi halves now. This is our first input here. Negative pi halves, then we went to 0, and then we went to pi halves. I'm going to label this one here. And then we went to pi. I'm just going to call this one pi here for a second. We say 3 pi halves. I want you to notice that we did go from negative pi halves out to 3 pi halves, which is a period length, okay, which is equal to 2 pi in this case. And we still are going to go up 1 and down 1, at least for this graph, kind of the sine parent function. So the only difference here is that when we were at negative pi halves for x, we were at an output of 0. So here we're on the ground. At 0, we're at 1. So we're up here. And we say, well, pi halves, we are at pi halves comma 0. And then we say pi comma negative 1. That's pi. Here's negative 1. And then 3 pi halves and 0. So we say, here's our sine curve. Okay, and I want you to notice this is the normal sine curve. Like, it has an amplitude of 1, a period 2 pi. The only difference is that it was all shifted left. We say, well, how far shifted left was it? And we say negative pi halves. So what effect did this c value, which, by the way, has a value of pi halves, what did it do to our graphs? It shifted at pi halves. So what would I do if I had, like, minus pi halves? So let's take a look at this. So if we were to plug in pi halves here, we're going to do a little bit of mental math, but sine of pi halves minus pi halves is sine of 0. When we say sine of 0, I remember this one, sine of 0 is 0. And then we say, how about pi? If I plugged in pi, well, pi minus pi halves is the other leftover pi halves. Okay, it's half of pi taken away from pi, you get left with the other half. So we say sine of pi halves is 1. We plug in 3 pi halves minus pi halves is just 2 pi halves, which is pi. Sine of pi, that's over here. We say that's 0. So we get 0. And I'm just going to save you the trouble here. We get sine of here, it's going to be 3 pi halves. When you take 2 pi minus pi halves, you're going to get negative 1. And then you're going to get back to 0 again. But this one comes out to be 5 pi halves minus a pi half. I can even write it. We say minus a pi half. That's 4 pi halves, that's 2 pi. So that's over here again, 2 pi. And that's 0. So we're going to put this on the number line again. It's just that we're starting at pi halves in this case. I don't know if you see the pattern here. We say this is pi, this is 3 pi halves, this is 4 pi halves, this is 5 pi halves. So one period length passed, still has an amplitude of 1 and negative 1. We can see that from our output values here. But we're starting at pi halves, we're saying at a height of 0, then to my maximum, then to 0, then to my minimum, and then to 0 again. So you could see that, what could we draw a conclusion from, from this exercise about the value of c? What conjecture could we make? We notice that when this was a negative pi halves, our graph actually shifts right pi halves unit shift. So shift positive pi halves. And when this was a positive pi halves in here, it shifted left pi halves. But you could see that this value of c is kind of backwards. So we say c is dishonest. And this is not a mathematical term. I just kind of use this term kind of as slang. But what I mean is, when it said negative pi halves, we actually shifted right pi halves. Positive pi halves shifted left pi halves. We also say that c is the horizontal translation. Okay, I'm not going to define it formally yet. There's actually a formula we can use to always find horizontal translation. But for now, I'm just going to leave it at this. But that's what you want to know about the value of c. We're also going to call this, just as a matter of knowledge here, we call it phase shift. When you talk about waves shifting left and right, we call it phase shift. Cheers.